Hey guys, we're just going to kind of give you a brief tutorial on how to use our new Thermo Fisher Scientific RIIDEye X GN. It's our new radioactive isotope identification device. Comes in a Pelican case, as you see right here. Identification number is 29590 for it. Once you pop the tabs in the waterproof case, you open the case and this is the contents. You should find the actual RIIDEye X put in the foam in this orientation right here. Should have 8 AA batteries stored in that pocket. This is the battery, the alkaline battery holder, which I'll show you how to use a little bit later on. This is the AC charger for it. The carrying strap, if you choose to use the carrying strap. And then a very important piece, which is the thumb drive SD card adapter. So to get the actual RIIDEye X out of the case, you kind of have to be careful. It's very tight in here to keep it from moving around. So you almost want to grab it with one hand and just work it out a little bit. There we go. Once it comes out of the case, it's very, very light. It's ergonomically balanced. You can see with just 2 fingers, it sits balanced just like that. Going over the real quick exterior functions of it, the RIIDEye X on this side of it has a port here. One is going to be for your charging. That's your power. And the other one's for your headphone jack if you want to be tactical. So the red dot here and the red dot in the front and the red dot on the other side signifies the area in which the sodium iodide crystal is actually looking for gamma radiation. So if you're in search for gamma radiation, this is the area here that you're going to be using. The actual neutron identification, the neutron detector, is going to be found in the handle here, which you'll see by the blue dot on either side of the handle. To turn it on, it's pretty simple. But before we get there, the serial port here is something we're never going to use. No need to touch it, no need to mess with it. That's for if you're linking this with a satellite communication device. So this is the basic display right here. Pretty simple to use. These are called hard keys. You have a back or a power key, a menu key, up, down, left, right, and enter. So to turn it on, just hold that key. It'll power on. It'll give us a welcome screen and run through a self-test.
Welcome.
Gives you estimated battery life right here, how many spectra are stored into it, and a few things like that. Takes just a few seconds to get booted up. Once it starts to boot up, it is automatically detecting gamma and neutron radiation. It can be used right now. However, notice the AutoCal step 1 and what percentage it is done. You really want to wait till we get done with that till we start actually gathering spectrums. It's very important for the sodium iodide crystal to get warmed up before it does that. While it's warming up, let's go over the display. Top left-hand corner here, that's going to be our battery indicator. Right now it has a rechargeable battery pack in it. This thing burns through batteries. You see where it says secure right there? That's short for security. That's the actual isotope library that we have uploaded into this. There's multiple isotope libraries. That's the one that's most prudent to what we're doing. Obviously the time. So when we go down to here, there's going to be our different dose rates. We have 3 different ways that dose rates are explained. We've got GPS, which is gamma counts per second. So let's go back to cancel there. There we go. Gamma counts per second. Neutron counts per second, which is always going to be in blue. And then we also have our micro rem per hour. Micro rem per hour. So this is about our background area here, sitting around no radiation. This is in dial mode. This thing will automatically always boot up into dial mode. Kind of gives you a no-go, go, no-go area. If we're going to identify radiation and the ticker is down here, we're not close enough to get a good spectrum. If it's anywhere in the green, you're close enough to get a good spectrum. If you get too close to high-level radiation, you'll go into the red and it'll say you're too close, move the device away. So these are the hard keys we talked about right here. These are known as the soft keys. The hard keys move the soft keys. There's a very, very short delay, so every time I press a button, like let's say the right arrow, it takes about a half a second for it to catch up. I can scroll back and all through. There's only 3 functions in the soft keys. We're in dial mode. If I highlight Finder and go to Enter, that takes me into Finder mode. Notice the soft key is still highlighted over dial, so I hit enter, it goes right back to dial. So I can either be in dial or finder mode. Those are the only 2 modes. Finder mode is wonderful, dial mode, which is what I'm in, is wonderful for trying to make sure I'm close enough to the isotope. Finder mode is great on trying to actually find a radioactive isotope. So as I'm scanning for an isotope in finder mode, you'll notice that the histogram, or a moving bar graph, becomes full of energy when I get close to something that's radioactive. So it's really easy. So when I get away from the radiation or get away from something that's radioactive, you can see the histogram went away and moved away from what was radioactive. Now as I get closer to it, the histogram becomes colorful again, like that. So that's a neat way to use the dial mode. Now, as you guys will remember for our policy, and you'll read about our policy, when we actually obtain a spectrum for analysis to go back to the state of Kentucky, we have to get 3 different spectrums. 1, we have to get a background spectrum. 2, we have to get a known source spectrum. And 3, we have to get the unknown source spectrum. So to get a background spectrum is pretty simple. Move the hard key over the soft key that's highlighted to background, hit enter. Now, when you do this, you want to make sure that you're not around any radioactive sources. In fact, it even prompts you. Ensure that there are no sources near the detector before continuing. If you know that you're not next to a source, you can just hit enter, and it'll be the soft key that's highlighted, which is continue, will move forward. You could also say wait, which adds more time to get the sources away, or you can go to cancel just to leave. So let's go to continue. Now, right now, it's obtaining a background spectrum analysis. You look up there in the left-hand corner, you've got our 7 different categories of our radioactive isotopes. If it comes back in blue, it's industrial. Magenta, it's special nuclear material. That other bluish color is going to be our medical isotopes. Green is natural radiation material. Yellow is uncertain, and red is unknown. That gray one that says C/B stands for Compton backscattering, and Compton backscattering is just a phenomenon where electron energy is moved up and down throughout the spectrum. It says acquisition complete in 28 seconds, 27. We can take away 30 seconds. We could add 30 seconds. We could erase, or we could cancel. We always want a 3-minute to 5-minute spectrum, but just for training today, we're going to keep it short so we can move past this video. So once it obtains that background spectrum in 14 seconds, it's going to save this picture that it gets to the spectrum file. It will not name it. It will just give it a numerical value. You have to know what number this spectrum was when it was saved. So this is where the pen and paper can come in handy, where you can write it down. Now notice the backlight turned off. I've got it set to turn off every 60 seconds. You can hit any of the up or down keys or over keys to get the light back up. All right, so let's go over here into something that is radioactive. Let's say we've got a radioactive source right here. Oh, radioactive 3, big stuff, okay? It's in front of our detector right now. Notice that once it gets next to a detectable amount of radiation that it finds to be higher than what the factory setting is, in gamma counts per second, it says red. It vibrates, it beeps, and it says high gamma, identify question mark. That's prompting you to go over to the identify marker and enter. Now you see where our arrow is almost in the green. We want to get this a little bit closer to the source and see if we can't get that arrow or that needle in the green a little more. And look, it is right there. So now that we're there, we're almost 1,000 gamma counts per second, 30 some odd microrem per hour. We're going to highlight, identify, and hit. You'll notice immediately our radioactive isotope identifier starts to go ahead and gather a spectrum. You can kind of see up here in the corner, it's listing the current gamma counts per second, the current dose rate, which is in microrem per hour, acquisition and complete in 3 minutes. Now it's prompting and saying 6 minutes are needed for SNM ID. That's saying that, hey, I'm not getting enough energy reading to rule out any special nuclear material. All that's saying is if you want the machine to rule out the special nuclear material, there's a program in here that does that, you have to keep increasing the time plus 30 seconds by hitting enter to meet that time frame to make it happen. Immediately, once we put this machine next to our source, it started coming up with something that says BA133, which is barium-133. Look at the color code, blue for industrial. Come down here, these are yellow spikes or uncertain spikes of other energies that are right there. I'm going to go ahead and cut off some time off of this just to shorten it up for the sake of the videotape. I'm going to take, there we go. All right, so it's done. It's analyzing and saving the spectrum, and here are the results that it came up with. Analysis report, write that number down, number 108. You know that number 108 in your file is what this came up with. Barium-133, classification industrial, confidence 99%. Anything less than 95%, we really don't trust that much. And this is some other information here that's going to have to be exported, which when you export the file, the next video will go over that. This is what's going to be sent to the state for analysis. I can go over here to back and move our detector away from our source, and we'll go back in our regular mode and we're ready to find our next isotope. All right, hope this helped.